Hello there, my name's Pete and welcome to another session of Electronic Assisted Astronomy with an 8-inch Schmidt-Cassegrain telescope. Now my CPC 800 sits on an alt-azimuth mount, which means its stubby little arms point directly up to the zenith. That's slightly unlike equatorial telescopes that are kind of orientated to what we call the celestial pole. And let me show you that. So this is pointing directly up from the decking where my telescope is on, and you can see the radiant pattern of the circles coming down in altitude all the way down to the horizon. And that grid is effectively how my telescope moves. Let me bring up the RA deck grid, which is orientated to the north celestial pole in this case, and as you see, it's different. And an equatorial telescope would follow the motions of this grid rather than the green grid. I use planetarium software, and this particular piece of planetarium software is called TheSky Professional. It has what we call field of view indicators. In fact, let me zoom in and I will show you. Here's one here in purple. And this represents the view my imager will see through my telescope, except it doesn't. Because as you notice, it's not really orientated to this alt-azimuth grid. It's actually orientated to the RA deck grid. So it's at a funny angle. It's not what I actually see on SharpCap when I look through. When I look at my screen in SharpCap. But EAA is about observing, so I kind of think of it as looking at it. So there we go. So I needed a way of making this orientate to what the view that I see on SharpCap so they match, because then it's far more useful to know I'm framing my target and what stars and objects are around the object that I've looked at. And unfortunately the sky doesn't support alt-azimuth field of view indicators, which is strange, because lots of them do. Stellarium, Starry Night Pro, Carlos do CL, they all have this concept of an equatorial mounted telescope and an alt-azimuth mounted telescope. So how to do? So I reached out to the community and they came up with this solution. If I click on my field of view indicator, I get these little handles and I can just move my field of view how I want it. So that's a solution that requires nothing additional. The only problem would be, of course, is when I now move my field of view indicator over here, it has to be changed again to orientate, but it's not too much of a problem, but you know. But the great thing about TheSky Professional, as with other applications like SharpCap and Astroplanner and Stellarium, is that it's got a scripting language built in called JavaScript and an object model that allows you to control it. So I just thought it might be possible to kind of take the hassle out of this and just run a script that automatically aligned the field of view of my RA field of view indicator to the proper orientation for an alt-azimuth field of view indicator. I thought that the field of view object model within the sky would do that, but alas, it's only read-only, so I can't set the angle of this rectangle that you're seeing on the screen. So the solution is to use a rotator, but I haven't got a rotator. But what I do have is the ASCOM simulator, can't even say that, simulator rotator. Let's look at how to create a field of view indicator first of all. So if I go to display, I go to field of view indicators, and here's one set up. If I double click on it, as you see, I'll put the description at the top. This is the size. This is the field of view for my imager, an Altair-Astro 294C, through a CPC 800 with an f6.3 focal reducer on it. Because I've been altering the position angle, this is the angle I've actually altered it to. I'm going to set that back to 0. And the reference frame is the center of the sky chart. So I want this orientated to the center of the sky chart. If I press OK, there we go. This is important. There's a little drop down that says link to rotator. So I click on link to camera's rotator and I press close. Now I need to set up the rotator. So I go back up to display. I click on the rotator. Up it comes. And I need to configure it. So I click on the little tool gear cog at the top. I go to rotator setup and I want to choose an ASCOM rotator. Press OK. I then want to set that up. So I go to settings and up comes the ASCOM rotator chooser. Now I haven't got anything other than the rotatorsimulator.net, so that's fine. And I want to set its properties. So this is its setup and this is the actual rotator. Now I've set the rotation rate to some incredible angle because I just want my rotator to immediately take on the angle that I pass to it. So I've set this to 720 degrees a second. Obviously normal rotators would be limited by the mechanical speed. Press OK and we're done. Now I can connect from here or I can connect from here. Let me connect from here. Oh, press OK first, sorry. So I connect and now I'm connected to my rotator. The next thing is to tell the rotator to move, and we do that via Tools and Run JavaScript. So up comes the JavaScript console, and here is the script that I wrote. In fact, let's bring it up in Visual Studio because it might be easier to understand. The JavaScript and socket start packet and end packet are to do when you send it via TCP from an external program, and I'll show you that in a second. But let's just concentrate on the actual script itself. The var out variable is just a way of passing information out of this back to the user, to the console in terms of JavaScript, or back out to the external program. I put it in a try catch, just in case I have any errors, and I would obviously return an error code to say, oh, that didn't work. The first thing I do is I use the object model CCD soft camera to see if there's a rotator connected. And if it equals 0, then it's not, in which case I tell it to connect because we've already set it up. And I send to the output the rotator's connected. I then check again, bit of belt and braces there, to make sure that really the rotator is connected, i.e. the answer coming back is more than 0. I then use this nifty little property that TheSky give you in their object model for the star chart that tells you that offset, that difference in angle between celestial and zenith. I put it into variable because I'm going to use it twice. I then use this fantastic little function here that says rotator go to position angle, and I pass in that angle, and then I output the angle that I've just set my rotator to back out to the console. And that's it really. So let's just run it and find out. So if I click on the run button, this should orientate to the green alt-azimuth grid. And it does. So now wherever I move in the sky, because I'm quite close to the pole right now, so it would orientate or rotate quite quickly, I just press run again. None of this messing around with the field of view indicator little tabs, just press run and away you go. Now that might be an adequate solution as well for you. For example, you can keep the rotator on a second screen over here somewhere. So you could just run it anytime you want. But another interesting feature of TheSky is it has a TCP server. It listens for connections and you can pass JavaScript to it, and which will then tell it exactly what to do. So if I close that and I'll just show you under Tools, there is a TCP server. You've got to have listening for connections set up. Okay. Once you have that, you could use a tool like this. This is a simple C# program, and there's a button that says Alt-Az field of view, and all it does is pass that script via the TCP port, and it will run. So if I move it and I click Alt-Az field of view, here's my output variable. The position angle is 104.56. So now wherever I go, I just click on my button and it orientates. Much easier than moving the handles. But there were 3 alternatives there. 1 was just doing it manually, 2 was just running it directly within TheSky, and 3 was to set up a little application of your own that would do it maybe on a press of a button, or maybe you'd do it every few seconds. It's up to you. Anyway, if you've got TheSky and you have an alt-azimuth mount, that might well have helped you. So thank you very much, and remember to have fun.